Okay, guys, example 5 from 6. We are ready to talk about our last example in 6.1 part 1, where we've been talking about vectors. Okay, we've been talking about magnitude and length of vectors. We've been talking about component form. We've added vectors. We've multiplied by a scalar. Example 5, we're going to find the magnitude and direction angle of each vector. Now, with that in mind, okay, note on A and B, you're being given a vector, right? And this vector is in what form? We have number, comma, number. This is our component form, okay? So I'm trying to piece back to Friday, because I know. Hopefully you've slept a couple of times since then. We don't remember. Okay, so if we go back up here to component form, okay, we talked about it kind of in this section right here, where we talk about the horizontal and vertical components. The horizontal component of a vector, A, is absolute value of V times cosine of theta. The vertical component of the vector, B, is absolute value of V times sine of theta. Okay? So, we're going to take our component form, our AB, and we're going to work to find, what was it, the direction angle and the magnitude. Okay? So, kind of a reminder there. So when it's saying direction angle, that means we're trying to find theta. What are we trying to find magnitude? What denotes magnitude for us? What symbolizes it?
The B and the absolute value.
Yeah, the absolute value. Whether it's absolute value of U or V, doesn't matter there, but I use U just because A is U. So, with that in mind, it says find the magnitude and direction angle. Let's start by finding the magnitude. How do we find the magnitude of the vector 3, 2?
B1 squared plus B2 squared and take the square root.
Okay, so if you recall, when it's in component form, it's the square root, and it's component 1 squared plus component 2 squared, right? Okay, so that's going to be 3 squared plus 2 squared. 3 squared is 9, 2 squared is 4, 9 and 4 is 13. So right there, the absolute value of U, I'm saying U because it's vector U, is the square root of 13. That is our magnitude. And it was helpful to find that first because we're going to need that for what we're doing. Okay? Did that at least come back to you a little bit?
Yes.
That was an easy thing, right? Okay. Now, direction angle. With direction angle, well, we have the vector 3, 2, yes? And we just talked about the horizontal component can be recognized as what? The horizontal component can be recognized as absolute value of U times cosine of theta. And what about the vertical component? It was absolute value of U times sine theta, yes? Do you see the connection I'm trying to make for you? The vector 3, 2 is also the vector absolute value of U times cosine theta, absolute value of U times sine theta. So what do we know? 3 is going to be equivalent to this first piece. And what about 2? It's going to be equivalent to this second piece. Am I making a little bit of sense?
Okay, so why is it U instead of B right now?
Because this vector was called U.
Oh my goodness. That's so, why didn't I see that?
Because the vector was called U. Now, what can be confusing is U is also used to note the unit vector, but it doesn't always mean the unit vector, so it does get a little confusing there. But because there's They have U as being one of the examples. Okay? Okay. So, we can set up two equations. Do you see that? Or really, we only need to set up one equation. Okay? So we can set up the idea of absolute value of U cosine theta equals 3. Now, what is the absolute value of U? Square root of 13, because we already found that, yes? So we could set up the equation that says square root of 13 times cosine of theta, and that's going to equal 3. Okay, that's the horizontal component. Or we can set up a similar statement with our vertical component, absolute value of U, so square root of 13 times sine of theta, and this one's going to equal 2. Now, you'll notice I put or in there, didn't I? Technically, they're going to give you the same answer. You can pick one and solve it. We don't have to work both of these. I mean, I'm going to work both of them just to show you, but we don't have to work both of these, if that makes sense. Okay? So, how do we solve cosine theta? And how do we get cosine by itself? I'm not going to say multiply by square root of 13, but divide by square root of 13. So cosine of theta is 3 divided by square root of 13. How do I find theta?
Do the inverse.
Okay. Remember, if it's cosine theta, and you need to find theta, and you know what it equals, you can do the inverse. So theta is cosine inverse of 3 over square root of 13. This obviously is a calculator deal at this point, right? And what are you getting?
33.7. Or do you want it to 2?
I have it to 2 on this one. We could go either way.
33.
Okay, and that would be 33.69 degrees. Because this is theta, yes? Now, should the other one work out the same?
Yeah.
Okay. And I'll say in this case it should. You could have just as easily instead shown that sine of theta equals 2 over square root of 13. And then what? Theta is sine inverse of 2 over square root of 13. Now, always stop and check. Does this answer make sense? As in, where is the vector 3, 2? Think just like an ordered pair, and where is that?
The
First quadrant, yes? Right 3, up 2. This is in quadrant 1. What kind of answer did we get? Positive, and in what quadrant? 33.69 degrees is in quadrant 1. So does it work? Yes. Now, why do I ask that question? Because the angles in other quadrants, you might have to adjust your answer. Like subtract from 360, subtract from 180, add to 180. You know, like you might have to do some various tricks to get your answer to land in the other quadrant. Okay? So just kind of an FYI there. But yeah, think about it. If we think about 3, 2, 3, 2 is what? Right 3, up 2. So you have a vector that does something like that. Does 33.69 degrees make logical sense then? Okay. Okay. Let's practice with B. Vector v is -2, comma, -5. What do you want to do?
Find the magnitude.
Find the magnitude. So, absolute value, and I am going to use v this time. Absolute value of v is equal to, what am I doing? Square root of -2 squared plus -5 squared. Folks, when we square negatives, what happens? They become positive, yes?
Yes.
Okay, not everyone knew that on the test. Just saying. You gotta remember, when you square a negative, the negative gets squared with it, it becomes a positive. So, okay, square root of -2, let's see, -2 squared is 4, -5 squared is 25. 4 plus 25 makes this square root of 29. So we have a magnitude of the square root of 29. Okay. Now, our vector is -2, -5. What am I doing next?
The direction of each one.
In order to find our direction angle, we've got to set one of these components equal to something that would represent the horizontal or vertical component. So you're either setting it equal to absolute value of v times cosine theta, or absolute value of v times sine theta. Okay? Both work. I know when I looked in the book just automatically does horizontal component. But either way, so let's see. What is my absolute value of v? So we can set up square root of 29 times cosine theta equal to -2. Or you could set up square root of 29 sine theta equals to -5. I'm just going to solve the horizontal component. What do we know about cosine theta? -2 over square root of 29. We solve for cosine. How do we find theta? Yeah, if you're trying to find the input, do the inverse. So cosine inverse of -2 over square root of 29. What do you get here? 111.80 degrees. Yes? Okay. Now, what did I mention on the last one? Check. Okay. Where is quadrant, or where is vector v? -2, -5. Is that quadrant 3? Left 2, down 5. Yes? What kind of answer should we have then, since it's quadrant 3?
Somewhere between 180 and 270.
You guys with her?
Yeah, no.
Okay. Our answer should be somewhere between 180 degrees and 270 degrees. Is that what I got?
No.
No. Now, I'm not saying we're wrong. Okay. Here's the deal. We just did cosine inverse. And I don't know how much you remember from chapter 4. But do you remember those half circles? Okay. Those were your output values, with sine and tangent being over here on quadrant 1 and 4. So if you had a positive, it was in quadrant 1. If you had a negative, they automatically gave you quadrant 4, because that's all the only place that sine and tangent inverse come out. This was cosine inverse. What are the two quadrants that cosine inverse comes out? 1 and 2, because it was up top. Okay. So that means in quadrant 1 is going to be your positives. Well, this was a negative, so it gave me the quadrant 2. Now, what we have to make happen is we have to turn this into a quadrant 3 angle. And this is where I don't have a good answer for you other than just kind of think it through and play around. It's that whole you're adding, subtracting from 180, 360 type thing. Okay? Now, and keep in mind, what was this? -2, -5? So we're going for left 2, right? We're going for something that's going to make sense, and that's that hole between 180 and 270, yes? In this case, how do I want to suggest this? Right now, it's 111 around this way. Okay, so think about it. 111 is going to be kind of up there, yes? And that was going that way. How are we going to get to this one?
Go the other way.
Go the other way is what I would suggest. How do you go the other way? Subtract from 360? Okay. So in this case, we're going to have to do 360 minus the 111.80, and we're going to get 248.2 degrees.
Wait, so we're not. Oh, 20.
Oh, 20, yeah. Okay. Does that make sense?
Do we have to do the other one?
No, you don't have to do the other one. Now, I will tell you, the other one is sine inverse. Okay, so for sine inverse, you get a different angle that you have to, you don't get the 111.8, okay, because you're not going to get that from a sine inverse. You're going to get an angle that is a negative angle in quadrant 4 that you have to work with. Okay, so it's just a matter of kind of visualizing and figuring out mathematically what you have to do. Okay, questions there? Now, this is the homework I had written down on Friday, yes? 5 through 8, 13 through 20, 25 through 34.
Plus.
And then, what did I add up on the board?
41.
I added 41, 42, and what do they go with?
The next.
They go with the example 1 in part 2.
Just the example.
Just example 1. So,
We'll never need to know example 2.
I don't know about never, but we are not doing it.
Perfect.
Okay, I changed my mind. I should have just taken it out of the notes, but I changed my mind in what I was doing. I can do that, right?
You are the teacher.
Okay, so we're going to go over to example 1 in part 2, and I think I'm just going to leave this on the same video. I'm not even going to change videos because. Okay. And you can read example 2 to get an idea as well. It's just more than I decide I want to go into at this point. Okay, so part 2, lesson 6.1, part 2. I really should just throw this example in with part 1. But part 2 goes into the applications of vectors. And one of the applications that they focus on a lot is that of an airplane. Okay, so a little bit of vocabulary. The velocity of a moving object is a vector because velocity has both magnitude and direction. Okay, and again, as I said, we're getting ready to relate this to airplanes. So the velocity of a moving object is a vector because velocity has both magnitude and direction. So you got that. Velocity is a vector, right? The other piece, the magnitude of velocity is speed. So when we start talking about speed, that is the magnitude of velocity. Okay. And technically, force is a vector's magnitude. I don't think we end up using that in example 1. I think that was example 2 that I mixed. So, okay. let's look at this example 1. See if we can make some sense out of it. A DC-10 jet aircraft is flying on a bearing of 65 degrees at 500 miles per hour. Find the component form of the velocity of the airplane. Now, there's a definition there. We've talked about this before, but the bearing of the airplane is the angle that the line of travel makes with due north measured clockwise. Okay, we've done this in a couple of different scenarios this week, but so when we talk about that jet aircraft has a bearing of 65 degrees, we're not going from our traditional 0 that is over at 3 o'clock. Okay, we're going from north, with north being up. Yes? Okay, so if we go for a picture here. Okay, there's my due north, yes? And what did it say? It's flying on a bearing of 65 degrees. Now, the bearing is the angle of the line of travel makes with due north measured which way? Clockwise. We did this somewhere back in chapter 4, I know. So,
Trying to explain to Emma which way is north. I'm right here. It's that way. No,
it's Kokomo.
It's that way. That's Kokomo.
Kokomo is north, Tipton or Indianapolis is south.
Ask Emma what she thought north was for the longest time. Straight. Like when you were going straight, you were going north.
No matter what direction.
Yes.
Okay. Fair enough.
Well, sometimes
Was there not a compass on your car telling you what direction you were going, or you weren't in the
There is
car?
one on my car. I don't know where it is.
It's not just automatically showing on the dash.
I took my little mid rear.
Okay, so where are we going for a bearing of 65 degrees? Measured from north, measured clockwise. So we're going to go 65 degrees
East.
this way, right? Okay, yes, to the east. And so when we do that, where are we going to end up? Northeast. Fair enough. So we're going to end up, I don't know. Is that about right? Okay. So the idea that 65 degrees is measured from north.
How do you know
It's because it said, no, we don't know it, but they use the word bearing. And a bearing automatically starts at north, which is the 0 for that sense, and it goes clockwise.
Are you going to make us know that?
Okay. Now, what this vector does, and I don't like my vector, I feel like it's up a little high, but oh well, we're going with it. Okay, that vector is representing the jet. Okay, that vector is representing the jet. And we know that this jet has a speed of 500 miles per hour, yes? Okay. Now, what information did they ask us to find?
The component form.
Component form. Okay. So when we talk component form, okay, this isn't where we have, like, when we first started talking component form on Friday, we had X and Y values we could subtract, right? We don't have that. We're talking in terms of angles, yes? Okay. So when we talk component form, we're talking, the component form we just used on the previous example, where the absolute value of absolute value of V times cosine theta, and absolute value of V times sine theta. That's where we need to get to have component form. Okay? Where this first piece is our horizontal component, and the second piece is our vertical component. Okay. Now, so we need absolute value of V. So we need magnitude. And we need a direction angle. We need theta.
No, we don't have I don't
Now.
know even.
Okay. Direction angle is probably the easier one. Well, no, the magnitude is the easiest, but I have to explain that. Direction angle. Okay. Direction angle is not going to be the same as your bearing necessarily. Direction angle is, okay, what have we been measuring? If I want to talk direction angle, I'm talking what? How far is this vector up from the x-axis? And how am I going to find that?
90. Subtracted from 180. Oh, maybe 9.
What are we subtracting it from?
90.
We're going to subtract it from 90 because together they make a right angle. So 180. Did not just say that.
Sorry.
I'm the one that said it. Maybe I was swayed by listening to the 90 and 180 and trying to decide, but okay, 90 minus 65 gives me 25. So that's my direction angle, so that is theta. Okay? That is theta. Now, the other part we need absolute value of V. We need the magnitude. There's a statement up top that's going to help you. Magnitude of velocity is speed. Do we know a speed? We do, don't we? That is 500 miles per hour. So we have a magnitude of 500. Or in other words, the absolute value of V is 500. Okay. Do we have the information to fill in to find our component form?
Yes.
Yeah. We need absolute value of V, and we have and we need theta. Yes, and we have those. So, and do remember that these are A and B, right? So in my notes, I have it written down as, yeah. In order to get A, the first component, we're going to do what? The absolute value of V, which is 500 times cosine of
25.
25. That's going to be a calculator thing, right? In order to do B, the second component, absolute value of V, so 500. This time it's O times sine of 25 degrees. Again, a calculator thing. What are you getting?
153.
53.25.
Okay.
And 211.3.
Okay, I can agree with those. So that makes my component form 453.15, comma 211.31.
Is that it?
That is it. Now, does this make sense?
When you explain it.
Okay. 453 to 11. And I feel like I drew this angle a little bit high. But if we go right 453 and up to 11, does that make sense? Like I could land on that vector.
Yes.
Okay, and that's the idea there. Okay, as I said, I feel like I drew it a little high. What this vector means here, okay, these are both speeds. Okay, so this 453 and 211 are both miles per hour. And someone made the comment earlier about moving northeast, right? That's essentially we're moving northeast. With that in mind, the horizontal component says this is moving 453 miles per hour in a eastward direction. because that's the horizontal component. And that means the 211, which is a vertical component, says we're moving 211 miles in a northward. Northward? Northerly? I don't know. Okay? And again, I'm trying to help you understand vectors and how they relate to airplanes. Okay? Okay. Your homework, written back on the other page, is what I had posted Friday, 5 through 8, 13 through 20, 25 through 34, and then don't forget to add 41, 42, if you're someone that wrote it down Friday. Okay?